Alright, we're going to take a look at taking derivatives, and the first one is example 8, and they have something like this. They want you to take the derivative because they're using this notation d of what, and you're asking you to take the derivative of the arc sine of 2x, and I'm going to show you two ways. I'm going to first show you the shortcut way. We found that derivative dyx if y is equal to the sine inverse of x, then dy dx was equal to 1 over the square root of 1 minus x squared. Well, I'm going to rewrite that a little different, and I'm going to write this as the square root of 1 minus, and in parentheses I'm going to put the x and I'm going to square it. And up here I'm going to take a look, and what this 1 is really the derivative of this x. So that means if I had something like in this case, I'm saying that y is equal to the sine inverse of 2x. My shortcut would be then that dy dx is equal to, now watch what happens here, it's going to be the square root of 1 minus 2x in parentheses, this part right here, squared times its with its derivative on top. And what's the derivative of 2x? It's 2. So my final result would look like this: 2 over the square root of 1 minus 4x squared. So that's using the shortcut. It's this idea that if I have y equals the sine inverse of a function g of x, that dy dx is going to be the square root of 1 minus that g of x squared, and on top is going to be the derivative of g of x. That's the shortcut. If you don't like that, you can do it this way. You can take this and write it in this fashion, that the sine of y is equal to 2x, and then ask yourself, okay, what does that mean? That means I have a right triangle. Y is in here. It's opposite over hypotenuse. This is the square root of 1, right, squared, minus 2x squared, which is 4x squared, right? And then you can do implicit differentiation, and I would have the cosine of y times dy dx, but instead of having 1 here, I'm going to have 2. So I have dy dx is equal to 2 over the cosine of y. But what's the cosine of y? It is adjacent over hypotenuse, which is 1 minus 4x squared. So this method that I showed you on previous videos can also be used here to find the derivative. So you have the shortcut part over here, and then you have what I call a long cut to be able to do it. Let's take a look at another problem, which is the next problem with the notes. Let's say that f of x is equal to the arc tan of the square root of x. Alright, so if you remember, when we had y is equal to the tangent inverse of x, we said that dy dx is equal to 1 over 1 plus, okay, there's my function squared, and here's its derivative. So in this case, I can say that y is equal to the tangent inverse of x to the 1/2. And so I'm going to have dy dx equal to, I'm going to have 1 here, I'm going to have x to the 1/2 inside these parentheses, and I'm going to square it. And then I'm going to take its derivative up here. Well, what's the derivative of x to the 1/2? Well, it's going to be 1/2 x to the negative 1/2. Alright, which can be rewritten as 1 times 2 times the square root of x. There's the 2, there's the square root of x, times the quantity 1 plus what's x to the 1/2 squared. That's just simply x. So I can get something that looks like this. That's the shortcut. Let's say that the tangent of y is equal to the square root of x, which means I would have a right triangle. Here's my y. Tangent is square root of x over the opposite over adjacent, and then this would be 1 squared plus this squared, the square root of that, and I would have the square root of 1 plus x. And then I would do implicit differentiation, and I have to have secant squared y times dy dx is equal to 1/2 x to the negative 1/2. There's that part. See, that's right here. And so then I have dy dx is equal to 1/2 x to the negative 1/2 over secant squared y, and I'll use secant squared. Secant squared is hypotenuse over adjacent, and so this is going to be 1/2 x to the negative 1/2 over the square root of 1 plus x, that quantity squared, and lo and behold, I end up with that as my answer. So either way will work. Alright, let's take a look at the next problem. And number 10 says we have h of x is equal to x times the arctan of x. Find the derivative. So the derivative in this case, the reason I brought this in here is because I'm multiplying, and so I'm going to need to use the product rule. So I have x times the arctan of x is 1 over 1 plus x squared plus the arctan of x times the derivative of x times the derivative of that, which is 1. And so my final answer, my derivative of h, is equal to x over 1 plus x squared plus the arctangent of x.